Okay, so today we are going to be graphing logarithmic functions. And we abbreviate logarithmic to log. We call them logs. Now, before we go about graphing a log, let's graph an exponential. This is what we did several days ago. Okay, so I'm going to plug in for x, I'm going to plug in a -2 up there. I'm also going to plug in a -1. We're using this equation right here. So 2 is the base, and we're plugging in the exponents 0, 1, and 2. Go ahead and plug in x's. All right, so now let's evaluate these. I'm going to start with the easiest one. Guys, what is anything to the power of 0? 1. What is anything to the power of 1? Itself, so it's just 2. And what is 2 to the power of 2? 4. Okay, now let's do these negative exponents. Remember, whenever you have a negative exponent, we're going to rewrite it and make it positive by putting it in the denominator. So this will become just 1/2. We're going to put the 2 to the power of 2 in the denominator. This will become 1/4. So guys, go ahead and graph those points in your graph. I will highlight these for you. First, you're going to plot the point -2 1/4, -1 1/2. These are the points that you're plotting. What's 1/4 as a decimal? Yes, this is also 0.25. So guys, go ahead and graph it. .25, 1/2. What is it? What is 1/2 as a decimal? 0.5. Okay, so we need to graph these. This is really small. -1, 0.5, 0, 1, 1, 2, 2, 4. So this is what your graph should look like. Okay, also, please graph your asymptote. This is your asymptote. Your graph will get very close to that line, but it will not touch it. Please draw your asymptote. It's right along here. So guys, what is the equation of the asymptote? Across the y-axis where? 0. So your asymptote is y equals 0. Now let's do the domain. The domain is the left side of the graph. It's going to go forever this way, and the right side is going to go forever to the right. So this will be -infinity to infinity. All real numbers. Now let's do the range. The range, you go from the bottom to the top. So the bottom is down here. Where is that at? 0. And then your graph goes up to infinity. So that is your range. Okay, so guys, this is what we did several days ago. We have graphed the exponential function. Today, we're going to be graphing logs. And the reason why we started out with an exponential is because they are inverses of each other. Exponential functions and logarithmic functions are inverses of each other. So if I were to graph this, it's going to look like that. You can fold it along the diagonal and they'll be on top of each other. It's a reflection across the diagonal line. Okay? So you don't have to draw that. This is what you're going to write. The inverse will be log base 2 of x. Notice that this matches. The exponential had a base of 2. The log has a base of 2. And these graphs, we will see that they're inverses of each other. Okay. So, since they are inverses of each other, what can you do to fill out this table? Yep, we're going to switch the y and the x's. Okay, so over here, I'm going to put these on the y side. So this will be -2, -1, 0, 1, and 2. We are switching x and y. Okay, and how do I fill out the y's? What will it be? 0.25, 0.5, 1, 2, 4. So because these are inverses of each other, that means the tables are just swapped. The x's and y's are swapped. And let's graph this. So the x-axis at 0.25 is right here, and it's at -2. So right there is the point. 0.5 on the x-axis is right here, halfway between 0 and 1, and that's at -1. 1, 0 is right here. Two, 1 is here. 4, 2 is here. So this is what your graph will look like. And notice that looks like a reflection of this graph. They're inverses of each other. Okay? All right. So let's answer these questions. Looking at my graph, what is the domain? Where's the left side? Yep, here's the left side right here. That's 0, and it goes off to the right, to infinity. Okay, let's talk about the range. What is the range? Yep, bottom to the top. All real numbers, -infinity to infinity. Where's my asymptote? X equals 0, right here. It crosses the x-axis at 0. Okay, exponential, we have 10 to the x. The base is 10. That means the inverse would be log base 10. Here, if I have the exponential function e to the power of x, your base is e, your inverse would be ln, the natural log. This is called the natural log. Okay, so guys, just based off of this, we're going to go ahead and describe the different transformations. I'm going to read it left to right. So guys, what does this negative in the very front do? Yes, thank you. It will be a reflection, so it'll reflect across the x-axis. That is the very first thing that happens to our graph. So guys, this is the x-axis. So the negative makes it reflect across the x-axis. So if this is the x-axis, this point right here will now be right here. This point right here will now be right there. You guys see how it's reflecting across the x-axis? You guys see that? Think of this as your mirror. They're looking across at each other. Okay? This point, it just stays there. Now, let's look at this. This point down here at -4 will go here at the +4. This is what your graph would look like. I just want y'all to watch. You shouldn't draw this yet. We're not done. I just want you to see what this looks like. So does everyone understand how the points changed when I reflected it? Yes? Okay, so let's move on to the next one. What does this -2 on the inside do? Right 2. You can write this down. Right 2. Okay, so since it moves to the right 2, I'm going to move each of these points over to the right 2 spaces. So this point will move over and be there. This point will move over and be here. This point will move over and be here. This point will move over and be here. So my new line looks like this. And I'll erase this old one. Is everyone clear on how we got that? Okay. Next, what does this +1 on the end do? Up one. So let's move each of these points up one space. So this will be here. I'll do it in a different color so we can see the difference. This point will move up one. 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 So it looks like this. So I erase the old one.
I'm not supposed to be drawing any of this.
Now you can draw it. We're completely done. Okay, so our asymptote, this is a log. That means your asymptote is vertical and it's right here. I know it's right here at 2 because 1, I'm looking at the picture, but then also it's always opposite of what's on the inside. Because this transformation went to the right 2, I know my asymptote is at 2. So for asymptote, everyone put x equals 2. Number on the inside, opposite. It went to the right 2, so it's x equals 2. Okay, let's look at the range. The range is always the same. It's just all real numbers. Negative infinity to infinity. That does not change for logs. Now let's look at the domain. It'll always be this number to infinity. Because look at your graph. It starts at 2 and then it moves to the right. It's going to all of these positive x values. And it's just getting bigger and bigger as it goes to the right. So that's 2 to infinity.